Okay, let's go ahead and finish 8.2.3. Some real quick questions here based on the graphs you're seeing. How many real roots do you see? So how many times does it cross the x-axis? That's really what it's asking. And I see 1, I see 2 real roots here. And then I see 1, 2, 3 real roots here. Now if I shift those graphs up just a little bit, how many real roots do you see now? So again, how many real roots are there? So there are 0 in this one because it doesn't cross the x-axis at all, and only 1 here. The key to this is understanding that we don't have any fewer roots in parts C and D, we just have fewer real roots, which means that there's some imaginary roots in here. So we have 0 roots, which means we're going to have 2 imaginary roots. Here we have 1 real root, which means we'll have 2 imaginary roots as well. So we've talked about how a polynomial function with a degree of n, highest power of n, will cross the x-axis at most n times. So a highest power of 3 means it'll cross at most 3 times. But it doesn't have to cross the x-axis that many times. So for instance, this graph intersects the x-axis once, while x squared plus 1 doesn't intersect at all. And then x squared minus 1 intersects it twice. And you can see those 3 graphs below here. The graph of a third degree equation might intersect the x-axis 1, 2, or 3 times. Take a second, pause the video, and make a sketch of all 3 of those possibilities. So here's what I drew. You may have something similar, you may have something different, but it should still be a kind of similar looking picture. The question that's really interesting is, can a third degree equation have 0 real roots? And the answer there is no. And the reason is we're going to have one side of our graph pointing up and one side of our graph pointing down, since we are talking about an odd degree. It means the ends go in opposite directions, which means that no matter how I draw this odd degree polynomial, it's going to cross the x-axis at least one time. Okay, so let's talk about this cubic graph. So here we have the graph of a cubic function. We're going to ask ourselves to think about how many real roots it could have. Now I want you to understand that's a slightly different question than how many times does it cross the x-axis, because where it crosses the x-axis twice, for instance, we're really seeing this is a double root, and we've talked about that. That bounce off of the x-axis implies it's a double root. So it's really 2 times that root. And then this is 1 root, so there's actually a total of 3, even though it only intersects the x-axis twice. So it could have 3 if it intersects 3 times or twice, or it could have 1 if it just intersects 1 time. We don't have to check this. I'm just going to tell you that this expression does factor to be this. Just believe me. If you want to check it, go ahead. You'd have to multiply everything out, but we're not going to do that. So what I want you to do next is to find all of the solutions for this expression. And to do that, we're going to use that factorization that we have up above, and we're going to find the roots. So to do that, I'm going to set each factor equal to 0 and solve. So if I set x minus 2 equal to 0, I get x equals 2. Now the x squared minus x plus 1, you instinctively are probably thinking that factors. It does not, I promise. You can try, but it won't. So we're going to have to use the quadratic formula here. So we're going to get x equals negative b, so 1, plus or minus the square root of b squared, negative 1 squared, minus 4 times 1 times c, all over 2 times a, which is just 2 times 1, so 2. And simplifying that, you're going to get this, which we can also take one further step and get this expression. So this is our expression for our roots, and what this is important to understand is that this is solutions, but it doesn't translate into real roots on our graph. So when we ask ourselves how many x-intercepts will that graph have, well, it's only going to have 1 x-intercept at 2, 0, based on what we did up above, where you see x equals 2. And then how many real roots and how many non-real roots. So it'll have 1 real root, and that's x equals 2. and it's going to have 2 complex roots. And that's the 2 that we found up above, where x equals 1 plus or minus I radical 3 over 2. All right, so let's do one more of these together here and make sure we've got this process down. So the first thing we're going to do is sketch the graph on the coordinate plane provided. Guys, you should be able to do this without too much trouble. It's just a parabola. It's been shifted up 4 units. Pause the video, sketch the graph, come back when you're done, and we'll continue. All right, so we've got our graph sketched. Now we're going to solve the equation to help us find the roots, because obviously I think maybe we can see that there are no real roots here. So how many complex roots do you think there will be? Maybe some of you are already understanding where this is going. If not, let's go ahead and find all of our roots here. So I'm going to take my equation, the x squared plus 4, and I want to set it equal to 0 so I can find the roots. So to solve this equation, this is a pretty basic equation until we get to this step where we take the square root of both sides, because that's what's new. So when we take the square root of both sides, we have to say plus or minus, and then we've got the square root of negative 4, which, guys, if you remember, that just means the square root of negative 1 times the square root of 4. That's all that's saying. So square root of negative 1 is I, the square root of 4 is 2. So really what we have here is plus or minus 2 times I. Those are our complex roots. So we have 2 complex roots. Okay, so go ahead and try a couple questions that we have for you on the forums, and then celebrate because you're done for the week. All right, I'll see you next Monday.